So welcome everyone to another video of constraints related questions. So in this video, we have to write a constraint for a 32-bit variable that is a int, and this variable should have around 21 ones. So in the 32 bits, there should be not 21, 12 ones. So there should be 12 number of ones. So the constraint should be a int with 12 number of ones, and there is a condition, so each of the ones cannot be consecutive. So there won't be like in the 32-bit there can't be anything like 1 1, then the let's say 0, then 1 1 1. It is not allowed. The pattern should have something like this: 1 0 1 0 0 1. So which basically means that there can't be two consecutive ones. So let's begin. I will write the name of the class as cons, and for this I would just write int, and that int should be randomized. So int a. So our first condition should be that there should be 12 number of ones. So let's write a constraint for that, and let's name this ones. So for this I will use a particular method which goes by dollar count once. So you just have to write dollar count once, and then it is followed by a bracket in which you will write the targeted variable. Here in our case it is obviously a, and you can just specify that how many ones you want this variable to have. So in our case we want to have 12 ones, so we will just write 12 and then a semicolon just to make sure that this constraint doesn't have any illegal specification or syntax. So our first constraint is done. Then our second constraint should be related to the repetition, that there can't be any consecutive ones. So for that, let's write constraint and a, let's write non-consec, and inside this we could just write for each. So it will iterate through each 32 bits of this variable, and we would write if that particular element, the value of that particular element is 1, then it should not be 1, which I mean then you just have to make sure that it should not be equals to the previous element. So I would just write I not equals to a I minus 1. So suppose if that particular element is 1, then it will check whether the previous element is 1 or not. Let's say if the previous element is 1, then it will automatically put a constraint that it should not be 1. And what's the other value other than 1? 0. So checking this condition, if the previous value is 1, then it ensures that this condition ensures that it should not be equal to the previous element. So it will automatically become 0. And if the previous element is not 1, let's say it's 0, then it won't change. Then then it is already not equals to the previous element. So it will remain like this. So on top of this, I will like to add one more condition, and that condition should be for the 0th element. And it is because uh, it is because of the fact that there is no previous element for the 0th element. It is the very first element. So I will just write and I will just write if I is greater than 0. So this completes our second constraint, which ensures that there won't be any consecutive ones. So let's move on to the top level module. So inside this, I will write the handle for this class. Just making sure whether I have made any typo or not. Okay, this should be fine. And after writing the handle, I will begin with the initial block. And inside this, I will assign the object to this handle. And oh yeah, I forgot to write the display statement. And I could just write it inside the test module, or I could just write it inside the class. So let's write this such a way that it prints the value right after when the randomization is done. And it should print the value in binary format. So let's begin. And for that, I would use the post randomize function, which is the inbuilt function. And inside this, I would just use the display system task. The generated pattern is, and I would just use the %p to print all the elements of not %p, it's an integer. So, and I want to display the value in binary, so I would just write b. And I would just mention the variable a. Now it should be fine. And here I would just assert the randomization of the class. Else, if the assertion fails, it will invoke an error. And let's keep it simple. So this is our total code. Now I will go ahead and check whether I have made any typo by running the compilation. Okay, the code is fine. So let's go ahead and run the code. Okay, so this is our 32-bit value in binary, and as you can see it right here that there are no consecutive ones. So our constraint did give us the desired pattern. So that's it for this code. The condition was to have 12 number of ones. Yeah, so we have to check whether we have 12 number of ones or not. So let's see. One, two, yeah, one, two, three, four, five, 6, 7, 8, 9, 10, 11, and 12. Yeah, we do have 12 number of ones. And the second condition was that there won't be any consecutive ones. And as you can observe it right here on the terminal that there are no consecutive ones. So this for the consecutive ones, this constraint uh, comes into action. So that's all for this video. Thank you so much and stay tuned for more constraint related questions. Thank you.